My name is Manender and today I will discuss about parity generators and checkers. First of all, to know completely about the topic, we should understand what is parity generators and checkers and why is it used and how it is used. First of all, to clear our why, we should come to the application of parity generators. In digital electronic systems, during data transmission and processing, data usually gets distorted. This is due to the noises added to it. Such noises changes data and zeros to ones and ones to zeros. It is necessary to identify and remove these errors because if we don't, then the data which gets transmitted won't be correct. One of the most widely used error detection techniques for the transmission of data and for sharing of the information between devices is called parity checking. Now, what is parity generator? Parity generator is the combinational logic circuit that generates the parity bit in the transmitter. A parity bit is used for the purpose of detection errors during transmission of binary information. It is an extra bit included with the binary message to make the number of ones either odd or even. To understand it, we can also say a parity bit is an extra bit in an binary message to make the total number of ones either odd or even. We add the parity bit to a signal. This is done by the parity generator. This parity uh, inclusive inclusive to binary message gets transmitted from the transmitter to receiver end. The parity checker then matches the number of ones at the receiver end with the transmitter end to check for the errors. If there is a change in the number of ones at the receiving end, then that signifies that there is a error in the transmitted data. There are usually two types of parity: even parity and odd parity. Even parity is when it means n bit input has an even number of ones. This is an example of even parity. Odd parity, it means n bit input has odd number of ones. Like in this odd bit parity, there are 0 1, and in this there are odd number of ones. So to make this odd parity, the odd parity bit is 0. And in the same way, if the scheme is even parity, then even parity bit changes to 1 and the number of ones will be even. Parity checker is a logic circuit that checks for the possible error in the transmission. The circuit can be even parity checker or odd parity checker depending on the type of parity generated at the transmitted end. When the circuit is used as even parity checker, the number of input bits must always be even. We usually use exclusive OR gates for idle for checking of the parity of binary number because they produce an output 1 when the input has an odd number of ones. Therefore, uh, an even parity input to an exclusive OR gets produces a low output, while an odd parity input produces high output. Now, even parity generator. In even parity bit scheme, the parity bit is 0 if there are even number of ones and in the data stream, and the parity bit is 1 if there are odd number of ones in the data stream. Like in the truth table of even parity scheme, we can see in this row there are odd number of ones. To make this even, the even parity bit changes into 1, and in this row the number of ones are even. Therefore it doesn't need any more ones to make it even, and the parity bits changes into 0. We can draw the cape map of uh, of this truth table, and we can solve the truth table using a sum and odd method, and this will be the equation of this truth table. In the odd parity generator, the parity bit is 1 if there are even number of ones in the data stream, and the parity bit is 0 if there are odd number of ones in the data stream. The truth table of the parity generator is this. In 3-bit message, like we can take an example of this row. Here the number of 1 is 1, hence it is odd. Therefore, odd parity bit doesn't odd parity bit changes into 0, and the total number of ones in the whole message are 1. Now, to check whether the transmitted data is and whether the transmitted data has error or not, they see the number of they see the parity bit. Like in the odd parity bit scheme, if the parity bit is 1, it signifies that in the normal message or in the original message there are even number of ones, and if in the transmitted message, if the no, if the number of ones is not even, then there is error. Like in the application, because of transient and noise and other disturbances, 1 bit error occurs when the binary data is transmitted over telephone lines or other communication paths. One way to check for the error is to use odd parity bit checker at the receiving end. If no 1-bit error occurs in the transmission, the received data will have odd parity. When error occurs, they are usually 1-bit errors. This is why the method described here catches almost all of the errors that occur in the transmitted data. There are different types of parity generator. ICs are available with different input configurations like 5-bit, 4-bit, 9-bit and 12-bit. A most commonly used standard type parity generator or checker IC integrated circuit is 74180. It is a 9-bit parity generator or checker used to detect errors in the high speed data transmission or data retrieval system. This IC can be used to generate a 9-bit odd or even parity code, or it can be used to check for odd or even parity in 9-bit code. We can see the pinput diagram of 74180 IC, and this is the truth table of 74180 IC. In this truth table, H means high level or high voltage, or we can represent it by 1, and L is shown by L means low voltage, and we can represent it by number 0. If we see the diagram of 74180, we can tell this IC consists of 8 message signal bits from 1 to 8 and 2 outputs. These are the 2 outputs. One is grounded, this 7 number is grounded, and 2 cascading inputs for even and odd. For the proper implementation of generators or checkers, unused parity bit must be tied to logic 0 and the input must not be equal. If you change the control inputs, you change the operation. Assume that the even input is low and the odd output is high. When the input data is even parity, the sigma or the sum of even output is low and the sigma odd output is high. In the same way, when the input data has odd parity, the sigma input output is high and the sigma odd output is low. At last, thank you for giving your time to hear this.